So for our second example, we have a homeowner purchases an 18% efficient photovoltaic collector with an active area of 65 centimeter by 80 centimeter for a cost of $230. If the average solar installation is 190 watts per square meter, this is a 24-hour average for the entire year. Calculate the payback period if electricity from the public utility cost 0.13 or cents per kilowatt hour. Note that this is exclusive of interest and costs associated with inverters and any storage system. So let's start to list down first what are the given here. So basically, the given is we have a solar photovoltaic cell, which is composed of several cells here. So this is a PV collector, and the size is 65 centimeter by, sorry, should be this one. This is 65 by 80 centimeters. So that's a given area. So we have an area of PV collector is equal to 65 centimeter by 80 centimeters. And then also we are given the efficiency of 18% of the PV. And then we are also given initial cost. So the initial cost are initial cost. So let's say cost here, initial cost. All right, cost initial is equal to $230 of this PV system, of this PV collector, and insolation is also given. So insolation is around 190 watts per square meter, and this is an average of 24 hours for the entire year. So this is the whole year. And then cost of electricity. So cost of electricity cost, so dollar per kilowatt hour of electricity, which is 0.13 cents. So this is 0.13 cents per kilowatt hour. And I think everything is already given here. And so the question is, find, what is the question here? And if we look at these given here, this is exclusive. So this doesn't include anything about interest, no interest. So we are not going to talk about interest here, and any cost associated with inverters. Okay, inverters plus storage system. So this one is purely talking about the PV collector itself. All right, so we are not talking about all of these interests and inverters and storage. So only the PV collector. So the question is calculate the payback period. So payback period. Payback period. So the pay period is time. All right. If electricity is from public utility, I'll say okay. Payback period of the system at an initial cost of $230. All right. So this is a payback period. So in terms of, since this is time, it should be in terms of years. Okay, we're expecting years because normally solar PV systems, we take years, months to years for the payback period. All right, so let's take for a solution here. So what is a payback period in terms of years? All right, solution. Power. So let's start with the power P. So we all know that power P is insolation, all right, times the area times the efficiency. All right, so we have this formula for power of the solar PV. So I think we better put first the different formula here. Letter B, what is the next step is to get how much is the value or the value of annual revenue. All right, so we need to know the annual revenue. So in this case, the annual revenue annual revenue is equal to the cost per kilowatt hour, the price of the the electricity times the total energy produced. All right, so the E sub T, which is the total energy produced by the solar PV, is in terms of kilowatt hour. All right, so this E sub T, okay, E sub T is equal to the power times time. All right, so if we have power times time, should be around kilowatts times hours. So it becomes kilowatts as an energy. So it becomes kilowatt hour. So if we have kilowatt hour there, so we can cancel this part here, so we can get dollars as the annual revenue. So that's the annual revenue that we need for the solution here, because we need to know how much is being or how much money we can get from the solar PV if we are going to sell the electricity to the utility grid with this pricing of 0.13 per kilowatt hour, 13 cents per kilowatt hour. So let's start first with letter A. Okay, so letter A. So power, again, insolation times area times the efficiency. So in this case, the insolation is given. We have 190 watts. Should it be watts? All right, should be watts per square meter times the area. So the area is 65 centimeter by 80 centimeter, and since this is centimeter and this is meter here, so we need to multiply this one with 100 centimeters 1 meter squared, right? So that we can cancel square meter. And then efficiency, so the efficiency is 0.18 or 18%. So we have the power of 17.784. So what is the watts? All right, so this is 17.784 watts. So this is just a very small system, because as you know, if you look at the problem here, this is a very small system, 65 centimeter by 80 centimeter of PV collector. So also the output power is also only around 18 watts. So now the question is to calculate the payback period. All right, and so when we say payback period, what does it mean? So payback period, so when we say payback period, this is the amount of time to that it takes to recover the cost of an investment. All right, the amount of time to recover the cost of investment. So if we look at our problem here, the cost of investment in this case is around $230. That's the initial cost. So we need to calculate how long will it take for the solar PV, the system, based on its annual revenue to take back the $230, which is the initial cost. So in this case, we can use letter B as our formula here. So we have the annual revenue is equal to the cost per kilowatt hour of electricity times the total energy. And we can also expand this one, the total E sub T. So dollar per kilowatt hour times, so we have already solved the power here, so E sub T is power times time. All right, and then so we have 17.784 watts times time, T, because now the T is the unknown now, because this is the time that we are supposed to find out how much will it take, so that this annual revenue should be $230, because that's how long it will take to recover the $230. All right, so we have T here now, so we can transpose now. So $230 over, so this one goes down here, so the price is 13, oh sorry, so 0.13, should this be 0.13 dollars per kilowatt hour, that is or 13 cents times 17.784 784 watts. Right? So in any case, these watts must be changed into kilowatts because we have kilowatts here. So we need to change this one into 1000 watts per kilowatt. All right? So we need to put like that as a conversion. And so we now have T is equal to, this one equals to 99,484 hours. All right. So we have in terms of hours. So now we can convert that hours into years. So how many hours in 1 year? So we can say 99,484 hours. Okay, divided by 1 year for 8,640 hours. All right, so we can say in 1 year there are 8,640 hours. So the answer would be 11.5 years. Right, so this is now the answer for this problem. So the payback period is 11.5 years. That's how long it will take for the revenue coming from the solar PV in this size here, as it has given here, small one, to recover the cost of $230. All right, so this is just a very basic example because this is a very small system. And so if we want to make a solar array, and so we can maximize the power and we can also increase the revenue coming from the solar PV array. All right, so for this case, the answer is 11.5 years.